Let's talk about monolith modernization with APIs and microservices. What I want to talk about today is a specific way how you can go through a modernization process. The idea being that once you've decided that some aspect of what you're doing needs modernization, how can you go forward with it and also go forward with it in a way that is not too risky and not too expensive, trying to minimize the number of changes you have to do and giving you the ability to only change those things that need to be changed. And what we'll look at today is a relatively simple pattern, how you can do that. And it's called the Strangler Pattern. And what I want to do today is briefly talk about why you might even want to do it. It shouldn't be something that you just do because others are doing it. You should think about why you're doing it. And then I want to tell you an easy way how to think about the Strangler Pattern and the steps it involves, so that you can start looking at it and maybe use that pattern to go through your modernization process in a controlled way, so to speak. So why modernization? That's a question you can ask yourself. It shouldn't be something that you just do because everybody does it. And speaking to large organizations, what we found is there are two main sets of reasons that emerge. One of these sets of reasons are more kind of a bottom-up motivation, I would say. And these often are originating from more the IT side of things, where there's the realization that a monolithic structure can have, for example, scalability issues. Meaning that if you have a very large code base and you have spiking demand for parts of your services landscape, scaling up that very large code base can become very demanding or just very expensive. And then the question is, can we do better than that and only scale those parts that need to be scaled? So in that case, the modernization drive really is originating in operational concerns, meaning that if you modernize, you'll be able to better match demand, better adjust to changing demand, and so forth. And microservices with containers, and in particular with models such as Kubernetes or serverless, are a good match for that. So the question then is, how do I get to that point where I can actually use microservices and get the gains of that approach that everybody is talking about? So that's the one motivation that we hear for why people do modernization. The other motivation that we often hear is a little bit more top-down, I would say, coming more from the business side, saying that the monolithic code base that we have too much represents what we've been doing in the past, and it's too hard for us to change that easily so that we can change what we do with our IT infrastructure keeping up with us. So the typical driver here is scenarios where the business side wants to change things, and then from the IT side you're realizing, oh, that is really hard to do because it's a complicated code base that we have to work with, and changing anything is a very hard process. So in that case, modernization drive comes more from top down. And here what we see is that the first wave of API focus, the good old SOA days, they did say that APIs are important, but they ignored the fact that for APIs to be really useful, it's not just important for APIs to be there so that people can use APIs. It's also important that the individual services that are provided by APIs are self-contained, so they can be easily changed, updated, maybe extended, which then leads to a better agility in how I can run my IT infrastructure. And either way, if you have any of those drivers, bottom up or top down, then you might want to go through modernization. But it's really important to think about the reasons. And I think that is something that people always should keep in mind. So typical drivers that we see when we talk to large organizations are an increased focus on business agility, sometimes also designing for change. So that's something where organizations also realize that probably they will undergo changes more frequently than they used to. That's an important observation, and something where you have to make sure that your organization is actually fit enough to be able to change at appropriate cost. The other thing that's also important are these operational complexity concerns. So how quickly, how easily can we adjust to changing load? Is that something we can easily do so that we can play around with different models, and then if something works well, we can actually handle it and maybe extend in this direction? And then sometimes it's also compliance and regulatory requirements, where there's the need, for example, to be sure that you can control where certain data resides, because that is part of the regulation, that you cannot just ship around data worldwide. You have to make sure that you can control where it is. So you also have to make sure that you know where this component is running, and maybe you can run it in different regions for different user populations. And this again can be complex when you have a monolithic code base that may make it almost impossible to develop those models. So for example, having different deployment regions for, let's say, for example, user data. So we see all these drivers that come in when we talk about modernization. And one pattern that I want to present today to manage this is called the Strangler Pattern. So what you see here is a strangler vine. It's a plant that grows around trees and slowly kind of grows around the trees, and over time then completely covers them, and at some point actually the trees inside dies and the vine is still standing. And that's the picture of the Strangler Pattern. The idea being that you grow this increasing set of replacement services around your monolith, and you do that in a strategic way. And at some point you even may be able to switch off your monolith, maybe not, you'll see. But the main idea really is to go through this process of having this growing set of services around your monolith. And I wanted to walk you through this process very briefly so that you understand what it takes and what the things are to keep in mind. And I've decomposed this process into 13 steps, but these are really easy steps. So bear with me and let's start to go through those steps. So number one, you start with a monolith and you should have some motivation. So you should know why you're even doing this. Don't do it because you feel like doing it. You should have a good goal of why you're doing it, and you should have also a good understanding of which components are the ones that really need to be replaced, because they do create concrete issues. Step two, identify those components and think about capabilities that you can identify where you say, it would be nice if this capability actually was available in a more decoupled way outside of my monolith. So that's a first step where you say, I think about this capability and I think about how I could define those through an API, access it, and ideally it would not be part of my monolith. The next step then, actually carve out this capability. Have well-defined boundaries where you say, this is really what I want to do when I talk about this capability. And that is what often you would call a domain. Identify a domain that you want to take, that you want to focus on, and that domain then becomes the domain that you're targeting in this one specific iteration of your process. Next step, understand how this domain actually works in your monolith. In many cases, in almost all cases, this capability in your monolith will also have some shared state. So it will use some database that is part of your monolithic code base. It will share state with other capabilities through these shared databases. This is the part that makes it so hard to modernize monoliths, that there's a lot of implicit coupling in there. But it's important to analyze what this looks like, because otherwise you will never be able to safely migrate those components out of your monolith. This is an important step, and it's important that you identify this shared state that you have in there. Now that you've identified everything that you need to actually realize this capability and to identify those code parts of your monolith that are relevant for it, the next step is to design an API for it. Meaning that now you define an API that allows you to access that capability in a way that is independent of your monolith. So it's an API, and anybody using the API can happily use it. And it doesn't matter whether it's in your monolith or somewhere else. For them, it's an API. So everybody then using this capability can start ignoring the fact that it's, for now, part of your monolith. So you're exposing this capability through an API. Let's move on. Step number 6. Now that you've exposed your API, you also need to manage it. So you need some security around it. Maybe you need some throttling or other kind of access control mechanisms around it. So you probably need some infrastructure for doing that. An API gateway would be a typical component for doing that. So what you start doing now is you start introducing infrastructure that you need for managing this kind of iterative process of creating those components, exposing them, managing them. And then as we move on, we will see how this gateway also serves some other functions. So now that we've exposed the API, people can start using this capability through the API. So they can start using it in an abstracted way. And what I can do is I can start, step number 7, to start re-implementing that capability in a standalone microservice. So now I start recreating my functionality, maybe even in an improved way. But for now, let's just say we're re-implementing it in some other place. And I can do that because I have understood what I'm doing there. I've identified my domains, and I can create a new implementation. Step number 8. I also need to access my microservice, and in order to do that, I should give it the exact same API as my original implementation has. So the API that you see here for both of these service implementations is the same API. That's important. Let's move on to the next step, step number 9. One of the things that is missing in many cases is the state. So my new implementation needs to be able to access data and information that my monolith is managing. And very often that means now I need to start replicating that data to my microservices implementation so that my microservices implementation can use the same data that my original service uses, meaning that now it's not only the same implementation, it also shares the same state. This part can be a little tricky, but it's important because you want this smooth transition, and often it involves some kind of database export and database import or any other actions that you may need to take to move that state from the monolith to the microservice. Once you've done that, you've successfully replicated the functionality and the state. And now you can actually expose the microservice also as something that people can use. So now you have to motivate people to actually switch over. There are sometimes very sophisticated schemes to do that. You can either hard switch everybody, or you can do some kind of traffic switching where some of the traffic goes to the old implementation, some of the traffic goes to the new implementation, and you make sure that always the same things happen. So that's a good way for you to see whether you've actually done well with your re-implementation. But as a general pattern, for a while, you will be managing those two capabilities in parallel, making sure that whatever you re-implement as microservice actually does implement what you want it to implement and works well. Once you're satisfied and you've decided that your new implementation is stable and good enough to focus just on that one implementation. Step number 11 is to stop using the monolith implementation completely. So your gateway now only exposes the microservice implementation. And at that point, you are also at a level where you don't need to make sure anymore that you synchronize the state. You might still do it because you're a little unsure. Maybe you have to switch back. But generally speaking, now you're kind of happy with your new implementation. So your next step, number 12, then can be you entirely retire your old implementation in the monolith. You remove any ability to share the state, and you now completely focus just on using the new implementation that is microservices based. What you've done now is you've gone through one iteration of carving out a capability, moving it out of the monolith, making it functional, taking it into production, and moving all traffic to it. And the last step now is not one step, it's many, many steps. Now you just repeat doing that. So as long as there are services that you think would be better implemented as a microservice, you just keep following the same process, meaning that you can carve out more and more pieces out of your monolith. At some point, maybe you can switch it off, but that's really not necessary to decide on whether you want to do this or not. For now, it's just a process where you go through this iteration if you feel like you really need to take one of your capabilities and move it out of the monolith. And this is it. This is the process that I wanted to share with you. To wrap it up, what I wanted to explain to you very briefly is that for this modernization strategy where you start from a monolith and you want to migrate, the Strangler pattern is a good starting point because it reduces risk. It allows you to do things in a strategic way and an iterative way. So there's no big bang where everything needs to be switched over from one to something else. It allows you to reimagine your capabilities as APIs one by one. So it's, again, a nice iterative approach. And you can do that by focusing on those capabilities that benefit most from modernization. So that's a good thing as well. Don't expect it to be super duper easy. You still need to identify and carve out those domains. That's hard work. It always will be. There's nothing around that. There's nothing that kind of makes that problem go away. So this is something you will always need to tackle. And also make sure that when you build those new microservices that you don't reintroduce coupling in some shape or form by, for example, starting to use shared libraries across those or sharing databases or doing things where you then start introducing coupling again that you just wanted to get rid of. So just be aware of that facet. And what you also don't need to do in my mind is from the very start to focus on very sophisticated deployment models. So maybe you don't need or want to use Kubernetes, from the very beginning. Maybe it's good enough that you have a microservices and you're happy with being able to deploy it faster so that you can make changes more easily and you don't need the sophisticated scaling methods that Kubernetes will give you. So you can be a little bit more, I would say, strategic in terms of deciding what do you want to focus on and what do you want to do maybe later on. And with this, I'm done. Thank you very much for listening. Like I said, my slides are available online. If you want to find them, you can find the URI that I'm showing you here. If you want to find some information about myself, here's some information about my identity on Twitter, YouTube, and LinkedIn. Thank you very much.